Yellow! I haven't done Advent of Code yesterday or the day before at midnight, so I haven't done the one for today nor the one for yesterday. A bit of a different setup today, but I think it should be fine. And I don't think this is gonna take too long. Let's see. Let's see. I was wondering today if my script that stores previous answers contains the timestamps for downloads, and it does. So here you can see we solved day 15. Wait. 2024, 15. Oh. That's strange. Wait, what was I just looking at? Anyway, so we solved day 15 at 12 and 22 minutes past midnight for part 1 and 2. And we downloaded it at this time. So, you know, all of the previous days that I didn't download right when the puzzle started, I can just take a look at this file and then see exactly when I solved it. Just quickly gonna rearrange my windows to show chat. Put you right there. Make it more narrow. Perfect. All right. Okay. So we got everything set up, I think. All right. So let's close all of these. We don't need this. Make this a little shorter and start the next day. I don't think I've activated this yet. Okay, there we go. We got a maze. And what's our goal? We're looking for E and we start at S. All right. So I think I want to start using NumPy arrays. I think it's just going to be a little easier to find the start and the end. And then we map all of these characters. So we got this is going to be a 1. And this is going to be a 0. Start is going to be a 2. And end is going to be a 3. So we should be able to say t equals where t equals 2, for example. So this should give us the start location. Yep, that works. And I think if we zip it, we will be able to get them a little easier. Not subscribable. I disagree. I think it is subscribable, my man. Okay, well, those aren't integers yet, but I think that's fine. So we got start is this, and then end is this. And then, you know, let's just test by printing start 1. Yeah, perfect. let's see if we got that right. Start and end. Yes, great. Okay, so now all we got to do is do a BFS of start can walk is lambda LHS RHS, where T RHS is not equal to 1. And then goal is, that's right. So I guess we don't need this one, do we? Okay. Too low. I think we got diagonals in there. That's my bad. Always happens to me. All right. We could have maybe gotten a winning time on this one if I would have done this at midnight and I wouldn't have made the mistake of including diagonals. Then again, there's like a 99% chance that at least 100 people used large language models to solve this one. Wait, before we submit this though, how do we get to the cost? Oh, rotate. Interesting. Okay, so we do need to define a cost function, which takes 2 values. I think this one is a little tricky because the cost method also needs to take into account the direction in which we're moving. So let's call it the move index. And then I think the options are going to be appended by the move index as well. Ref move index. And which direction do we start? We start by facing up, I guess. Facing east. Okay. So east is gonna be, let's again make sure this one rotates 90 degrees by increasing the movement index by 1. So we got up, right, down, left, and we start with an index of 1. For position, cost, ref move index. Great. Okay. So how about we call cost function with ref move index and move index. And since we're never going to return more than 90 degrees at a time, we just return 1 if this, and then otherwise 1000. And I do want to test this and run it with this test input. And we get this number, which is not correct. I see. So we should actually optimize for the min solution. If goal and cost min solution equals cost. Return min solution. Well, the value we got is lower. No, it's not. We're supposed to get like 7,000 or whatever. Okay. Let's see. It was 1,000, right? I didn't get that part wrong. Yeah. I don't think we can do this with BFS. I think we have to do it with A star or something. Because visited. Well, how about this? Visited should instead be a dictionary of start and cost. And visited less than the current cost. Then we continue. There's no attribute add. You're right about that. So let's do visited UP equals cost. Okay, I think that's right. Nope. It's not. How did that happen? How did that happen? Okay, well. I don't know. It is surrounded by a wall, so we don't need to do too many checks here. You can walk anywhere unless it's a 1. I agree with that statement. We start where t equals 2. We're trying to go to t equals 3. If we're not turning, then the cost is 1. Otherwise, it's 1,000. Let's see. How could it be possible that we are like 4 short? Or 7 rather. Oh, because the cost is 1,001. Oh, that's stupid. That's so stupid. Ah! Okay. You got it. Okay. Wow. Okay. Are part of any best path through the maze. There are 45 tiles that are part of at least one of the various best paths through the maze. Okay. Wowee. So we need a full history of spots we visited. And this is no longer less than equals, it's no less than. So let's print BFS 0 because we're now also going to return the path. Path. So we do that by, instead of taking a look at the position, we take a look at the history. And options is now this. And this is, I think, history plus and then we take a look at all paths, which is currently an empty list. No, an empty dictionary. And then we do paths. Jeez. Not in paths. There we go. Okay. So this still works. So how about we take a look at this one? Paths is 1. Print paths. Okay, that looks about right. Yes, that's better. Okay, 2 separate paths. How many tiles are part of at least one? All right. So I think we just return the sum of the len of p for p in path. No. What? Oh, I forgot a parentheses. Okay, 74. Is that right? No. In the first example, there are 45 tiles. Oh, I see. I see. S is equal to set for path in paths. For x, y, and path, s add print len of s, I think, right? 44. I think it's just a +1 angle because I think we're forgetting the start position. No, it's not. So we are doing something wrong. What are we doing wrong? Well, I guess we shouldn't be ignoring the start and the end position because we are appending the entire history, including new p, which new p is the goal, and the history starts with start. So they should all be in there. Okay. Let's see. It looks like we might be better off taking a look at the second example. Looks like we'd be better off. And then this one is supposed to have 64, I think. This is 63. No, okay, see, this is way too low. All right, so why is this too short? All right, so how about we take a look at a set of all histories visited. This is probably going to take way too long. I don't know if it's going to take way too long. Maybe it's going to take way too long. Visited. You know what? I think what I'm going to do is write another method that has an upper limit. Let's call it limit BFS. Limit equals 0. So we got limit BFS, and then the limit is this, I think. Okay. So we don't take a look at visited as a dictionary anymore. We just take a look at it as a set. And now we see if hist, this is the new path. New path is equal to this. And then we have a tuple, which is just the tuple of new path. Okay. Visited, I guess, is a set of a tuple of start. Right? Maybe. I don't know. Should be fine. Should be fine. All right. Visited. If cost greater limit continue, visited dot add this. That should work, maybe. Infinite is not defined. Did you mean int? What do you mean infinite is not defined? Yes, it is. Oh my gosh. When did I remove that from my template? That's silly. That's super silly. Okay. This is taking too long. Why is this taking too long? We will never go to the same spot twice, that's for sure. Okay, I think we got it. What? Oh, my input is way bigger, so it is going to take a long time. But I think it's fine. It might take a few seconds here, but I think we should be fine. If we can get to this one in like less than a second. This is certainly not optimal. But I think it's going to work. I think we're going to get there. Like here, we just remove backtracking. We never want to go to the same spot in one path twice. This one is certainly a very important line. I have another idea. We don't really care about the order of our history. So I don't know, can we throw out paths that have the same history in a different order? Maybe, maybe not. We need to take a look at the minimum. Okay, this is not going anywhere. This is not gonna complete. Yeah, whatever. So I think this might actually be a dictionary of visited, and then we do a tuple of start and then the cost. What am I doing? I think that might be right. Like, how about we say visited if new path and visited and okay, let's see, and cost greater equals visited, then we continue. Is that right? I don't know. Visited equals cost. Let's see. I think that should prune a lot of new paths, but we're still not pruning enough paths. What other path are we forgetting about? I don't know, man. I don't know if we can cut out any other paths. We're already looking at the limit. We're already only taking into account paths that are new. We don't even care about the order of visited spots. I don't know. Maybe I just leave this running for a while. But I know this is not the right answer because I know you can do this much faster. Blah, 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 blah. I don't know, this is a tricky one. I might have to think about this a little more. This might be a depth first search angle. For no particular reason. Just maybe we're cutting up more paths this way, but I don't think so. No. tough. This is a tough one, huh? I'll think about this for just 1 second, and I'll be right back. I don't know, man. I feel like I'm already pruning so many different paths. Um, I feel like I'm already pruning so many different paths. So we know that what do we? We don't really know that all that much. Yeah, I don't know, man. What does the maze look like? Start, bottom left, and upper right. Okay, here's what we could do. We could find for every single spot the minimum distance to the end. That's not going to take too long. So we would do, well, let's forget about limit BFS for now. Or rather, we're going to re-implement limit BFS. So let's say BFS, we never care about the paths anymore because that method is never going to return the right path. So we can remove all of this logic. And this, that might speed it up a little bit. I don't know how much. AOC solve 1 AOCR. I mean, it's pretty quick. Might be able to do it for every single spot. And that was the right answer, right? If we cat the answer log, it's 106,512. Okay. So here's what I'm thinking, all right? I'm thinking for x and y in zip and p where t equals not equals 1. Min dist equals min dist of x and y is equal to BFS. I mean this thing right here. So instead of start, we do x and y. And just as a sanity check, how about we print, I mean this we'll probably need later. We print min dist of start, although start is currently not defined. Start is right here. Oh, maybe start is defined. Okay, let's see. So AOCR is going to be super quick. This is going to be a little longer, but it shouldn't take infinitely long. I mean, it's going to take too long because my algorithm sucks. What? $10,000 times? It might take very close to 10,000 seconds, unfortunately. Is there any faster way to do this? Probably? Oh, man. Oh, man. Oh, man. I think what we should be doing is reverse the search. So we start with the endpoint. We try to find every single spot. We try to find every single spot without turning. Then we allow turning once. Then we allow turning twice. Blah, 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 blah. I think that's the right solution here. So how do we do this? Ah, man. All right, so let's implement all of this from scratch. Okay. Well, we're never going to turn more than the maximum amount of turns. So I'm going to say what am I going to say? Let's just change. Okay, we're not going to use this ever again. We're going to take a look at the BFS. We take a look at the min solution. We include whatever, 99, 99. And turn. Here's the thing, though. This doesn't work. That's the thing. Okay, Let's not do this. Let's, I don't know. Let's start with a heuristic of, say, we allow 10 turns, and then we go from there. Let's say we allow... No, wait, I have a better idea. Okay. So all spots are lists where t not 1. Those are all the spots, except it's not a list, it's a set. Print all spots. Great, that looks about right. So while all spots turns allowed is 0. Turns allowed plus equals 1. Start is this except a list, and then the first one. And we say it's 3, which is actually the end. Is that right? Start is 2, the end is 3. Yes. All right. And now we re-implement BFS. Kinda. So the options are start 0, which is the amount of turns, right? I don't think we need this one anymore. Maybe. Ah, man. Man, oh man. Let's just try doing it without this stuff, and we'll add it later if we need it. All right, so for position, cost, turns in options. And again, min dist is empty. Let's say this, right? So the end is 0. Okay. While options, new option is empty for position, cost, turns in option. I don't think this works. I don't think this works because we can't just do the cost for a specific spot. We have to do the cost for a specific spot and a specific orientation. Oh man. Oh man. Oh man. Man, I'm not having a great time. So, we got end 0, 1, 2, 3. Didn't copy the full thing. 1, 2, 3. All spots is a set of nothing. And then for position in this, all spots at 0, 1, 2, 3. There we go. Start. Screw this. Because we got start 0, 1, 2, 3. Okay. And then we got pause, turn, and the position and the turn is equal to pause, turn. Great. I think that's right. Now, we calculate a new position. We have a bound check. Assert t new pause is not 1. Plus 1 plus 0 if turn is equal to move index, else 1000. Is it 1000? I think it's 1000. And then I think all we got to do is take all spots, remove position T. If new position not in all spots, continue. And then we say minimum distance. Add turn is this. There we go. Okay. So we're making some progress here. We got min dist. Oh, fuck me, this is wrong. These are all the values that are supposed to be here. Great, okay. I don't think we need this, actually. I think all we need is if position in MinDist continue. I mean, yeah, the whole thing has like a width and height of 140. So one turn is never going to be optimal if it adds a whole 1,000 to it. Walking in straight lines is always going to be beneficial. Let's see. Visited. Visited doesn't exist. MinDist new position is equal to cost. I think that's right. Okay. So we still need to fill new options with the right value. And it's going to be this ain't right. This ain't right. Oh my gosh. New position turned is equal to new position move index. If new position turned in min, there we go. That's more like it. Screw this stuff. And then we append. What do we append? New position turned, the new cost, and then the turn plus one of turn else 0. I think that's right, right? So then it's true and 1 if we have to turn. And then we say if turn is plus a turn, then we continue. Great. Okay. Let's see what happens if we run this. While all spots. You're kind of right about that. Let's say added new is true, added new is false, and we set added new whenever we do this, maybe. Start. Yeah, I don't think we have a start. I think we have an end. E000. Okay. Don't be cute now. All spots. All spots. Ah. Got it. Okay. Move ID X. Yes, you're right about that. All right, that was pretty quick. That was pretty quick. That was also pretty quick. I think we now have the minimum value that we can get for all of these positions. So for all of them, we now know the minimum value to get to the goal. And now all we got to do is go backwards and figure out if a position. Did I delete the BFS limit method? I did. Shouldn't have done that. Okay, well, how about you give me the len of MinDist. $16. Well, that's not right. Oh man. How's that possible? Even with 0 turns, we should get at least this many. God. Cost turns. Position turn. Cost turn turns. Oh. I feel like I'm really overcomplicating this. Maybe I'm not. I don't know. I don't know. Ugh, let's see. I don't know what's going on, to be quite frank. I don't understand how it's possible that we have 16 values in our MinDist and not a single one more. Because if we add an additional allowed turn, then we should be getting new values. I think we need to do this differently. I think we need a set of options. Oh 0 for row and options. I think that's right. Well, now it's taking forever. Okay, wait, now I have a better idea, Okay. There we go. Okay. Maybe. That's more like it. So now we're taking a look at all the ones that we were a turn short for the next time around. So we got 20,000 periods, which is, you know, on average, every single spot twice, because we got 2 different directions for every spot. I think that makes sense. I think it makes sense. Okay. So now we know how far every spot is away from except one thing we need to do is I think this. We want to rotate it at reverse because we're going backwards. That's right. Okay. So now if you're facing a certain direction, so, you know, another sanity test, sanity check is to take a look at the end, turning east, and we should get Mindest and start east, and we should get the same value. We're not quite, but it's very close. That's interesting. How are we adding 4? I think it's probably not 2, not 1. Maybe it is 1. What did we get for 3? 3 is not possible. That makes sense. That does make sense. Okay, why are these 2 values different by 4? That kind of sucks, not gonna lie. And this one we don't even get to the starting point. Okay. I clearly don't know how to solve this one. And I think I need some time to think about it. I'll get back to this. Let me see if I can think of a solution. I think I don't. I mean, look, finding the shortest path is easy. Limiting I could do this with an A star, but A star depends all on the heuristic that you're taking. Yeah, you would think that the algorithm I wrote to like find the shortest path from every single spot is correct, but I guess it's not. So we're probably doing something wrong. Something wrong. I think there is a chance that so we try going straight in all directions, and then we allow turning once, and we go straight in both directions, and then we allow turning once more. Now, all of a sudden, there might be two different ways in which we can reach a spot. And maybe that's it. Like if we allow, like we don't so min-dist is yes, okay, great. In min-dist and min-dist less than equal, then we continue. All right, let's see. Still nothing. That's strange, isn't it? That is strange. Well, let's maybe cast to int, but I really doubt that this is it. Really doubt it. Because these are like NP in 64s, whatever. But come on, like if that's it, that's insane. Start, and this is equal to 2. Highly doubt it. Yay. That would have been insane. Okay, well, So we go straight all the way. We turn. every time we can turn, we append it to next options, which is, you know, 1 turn away from where we are currently. It is very strange. It is very strange. So I think what we got to do is for direction in range 4, I mean, we know that start is always in the bottom left, right? So we should say if start 1 in MNDIST, print, and then we have start up is 0, right? Yeah, up is 0. This plus 1,000. Oops, this is going to be a 0. There we go. Okay. There we go. Great. So now we found all the possible paths, or rather the minimum distance for every single spot. So the limit is infinity. Limit is min of limit. And this. And this plus 1,000. So now we got the same value twice. Okay, that's great. All right, wait, give me 1 second. I'll be right back. Okay, so we have the minimum distance from every single spot, right? So now we have search heads, which are start, 0, and 0, and start. So that's not quite right, because the cost at 0 is going to be the cost at 0 is going to be 1,000. Is that right? Because we already turned once. Let's see. And then we got for position with turn and cost in search heads. And then we got the position and turn is position T. And for move index and distance, new position is this. If new position, no, actually we don't need that anymore, because we are gonna check if it's in min. Let's call this the new turn. If cost, okay, no, if not, new position, new turn in Mendes continue. Is that right? Is that how this works? I think so. If min-dist of new position and new turn plus the current cost is less than equal, no, let's just do this, continue. New search is empty. And here we do new search heads is new search. New search, append, position, turn. New position, new turn, cost plus 1 plus 1,000 if turn changed. Okay, so now we want to add to the search heads the history, which is going to be a set to make it easier later. Great. New search, append, and then hist plus the new position. Great. And then if new position is equal to end, then all visited is an empty set. All visited, yes. Amazing. And then we print the len of all visited. I mean, maybe this is right. Maybe this is right. Okay, well, that's not quite right, is it? For position cost history, position cost history. New search append. What's your problem? What the hell? What the hell? I think we do have to do better. Like, I think we need to store the MNDIST not just for the spot, but also for all other rotations. Which should be easy to do, I think. And then we can properly do this. Okay, so how do we do this? By doing or KV in MNDIST items. We got position and turn, or turn in range. No, we can turn 1, 2, or 3. And then the cost is 1,000, 2,000, 1,000. Turn. If position turn not in MNDIST, then we do this. Yeah, let's see. What? Dictionary change during iteration. Yeah, but who cares, to be honest with you? Let's turn it into a list, maybe? Yeah, there we go. Okay, better. I think. Add turn. And then cost is equal to add turn. And then turn is add turn. Yes, okay. That's better. Let's call it new turn though, because I think otherwise we're messing up. I think we do 1, 3, 2, so that we do this one first. No, this is silly. We need to make sure that or the min-dist greater than v plus cost. Okay. So let's see. We don't want turn anymore. We want new turn. Okay, finally. Jesus Christ. Can we run this now? I don't know. Maybe. Maybe. Yes. Oh my gosh. That took forever, dude. Okay. So what did I do the last 30 minutes? Well, we were trying to figure out which paths we have to take into account. We always can cut out paths that have a maximum distance, no, a minimum distance from the spot that we're going to plus the distance that we've already traveled that's greater than the optimal path, and we just prune them. In order to do this, we did a shortcut where we take a look at the things we can reach without turning anymore. We add them to the list, and only after having taken into account all of them, that's when you start adding another turn to it. We do that by keeping track of the next options, which are all the ones that are one turn away. Then we still gotta, add all of the options that we haven't taken a look at by going to every single spot in the map and then turning once, twice, thrice, adding either 1,000, 2,000, or 1,000 to that distance. Oof, that was rough. That was rough. All right. Let's see. What was this? Day 2. I don't even know if I've tested this one, but I think I did. Okay. Add day 16. Great. Okay. Now, hopefully day 17 is going to be easier. I kind of hate these sort of assembly code puzzles. This program is a list of 3-bit numbers. The number knows 8 instructions, each identified by a 3-bit number. Its operand number called instruction pointer identifies the position in the program that starts at 0. The computer tries to read an opcode that's passed the program at false. It will run the instruction 0, which gets the operand 1, then run instruction 2, which gets 3. There are 2 types of operands. Each instruction specifies the type of its operand. The value of a literal operand is the operand itself. For combo reads 0 to 3 operand 4 reads register A, B, and C. 0 performs division. Jesus fucking. Oh, I don't feel like implementing this right now. I think I'm going to take a break. I'm going to take a break. I haven't really eaten anything all day. I will get back to this at some point today. Ugh, I don't know. I kind of want to be one of the first people to ever get 500 stars, which means by the end of day 24, I have to have solved every single previous day. Wait, I'm kind of curious before I leave if many people were struggling with day 16 or if that was just me. Stats, day 16. No. Seems like more people struggled with the day before than with today. Very interesting. All right, well, most people apparently struggled with day 2 and 6, which is very interesting. Six. I don't even remember what 6 was. Take a look at 6. And remember from reading my code or the input. Ah, the stupid robot running around, or the guard or whatever. Yeah. Huh, part 2 was pretty easy. I guess you really must have messed up implementing part 1 for part 2 to be causing you runtime issues. It's so strange how few people had a problem with day 16. I really struggled there. Probably went a little overkill on my day 16 solution. Yeah, I can't help but feel like replacing like a less than with a less than equals or something might have solved this one without like going overboard. Nah, whatever. It works. I am very hungry and a little out of it today. I'm gonna blame that. Oh, and my phone is out of battery. That's great. Yeah, I'll come back to part 17 in a bit. The fact that only 50% of people have solved the second part makes me a little nervous because I feel like it's going to be one of those, oh, you need to understand what this program is actually doing. So like, you need to convert the assembly code into like math in order to understand like how to speed it up. Not looking forward to that. All right, I'm gonna get some food and I'll be back later. Maybe at midnight today to do day 18. We'll see. All right, bye-bye.